Greetings, Mathies. We are checking out the beginnings of statistics. And so at the top of your notes, you can put 3.1 data sampling and representation. It's out of chapter 6, sections A and B from the textbook. Here's some statistics. 6% of shark bites are to the head and 32% are to the legs. Now, those are statistics, right? That's somebody took some data and that's what they found. How you portray the statistics is a different thing, because some people would say, hey, look, you're less likely to be bitten in the head, so when there's a shark near you in the water, put your head in the water first because they're less likely to bite your head. Statistics is about portraying a story, and that part can be skewed. What we want to do today is look at the basics of how we take data and how we portray it. Here's some vocabulary. I want you to make sure you know what you're talking about. Population is the whole group, and we can't always ask everybody in the whole country what they want, especially if you're in a bigger country. So we take a survey and we take a little sample of that, and hopefully your sample represents your whole population. We'll talk about these types of different data in a bit, and we'll talk about outliers and distribution, but just kind of take a look through those. All right, when we are sampling, when we're taking data, there's different types of data that we can take, and one is like qualitative data, is like how you feel about something or the quality thereof. Categorical data is like a category, a brand maybe, and quantitative data is with numbers. We're going to focus mostly on quantitative data. These are nice for old people and children. Mathematicians like quantitative data with numbers. Discrete means that they're whole numbers, things that you can count individually. Continuous can be decimals, and I'll give you some examples of the difference of that. So maybe the number of brothers a person has sounds like discrete. You wouldn't have 4.32 brothers. Maybe you want like one less or something like that. The color of lollies in a packet, maybe that's categorical, right? You can have blue and you can just count the number of blue and purple and red. Time children spend brushing their teeth, continuous, etc., etc., etc. So let's look at each one of those a little bit. Categorical data is in categories, right? So you could take everybody in the school and maybe you can see the frequency that in class you have nerds or jocks or hipsters or punks, and you could make some tables. This is a histogram or a column graph, or you could turn it into a pie chart, right? And so this is the display of categorical data. A column graph tells you, and they should be the same, like there's 8 out of the total. And if you looked at the proportion of these 8 out of what there's, let's call it 40, right? That would be the same proportion as this angle out of the total. We're not going to build a lot of pie graphs, but just so you can see how that might be done. When you're sampling, taking data, you can do that in a bunch of different ways. This convenience sampling is what everybody does in middle school when you ask your friends about their favorite movie, right? You just like look around who's around you and ask the people in your class, but that's probably not representative for all the students your age. So convenience is just like who's nearby that I can sample. Random sample would be just picking people off the street, right? As they walk by, you pull names out of a hat, and you really just randomly sample everybody I can't ask everybody in the school what their favorite book is, but I'll just pull names out of ISAMs and hope that my little sample represents the whole population. That's that. Systematic sampling is a little more like picking every 20th person. So you're randomly it's random, but you're doing it more systematically than just like picking some people out. It would be like standing at the door. Random sampling might be just standing at the door and just pulling people and surveying their favorite book just by whenever you want to. Just pull one person here or there as they're walking down the street. Systematic sampling would be the same thing, but you'd wait for every 10 people that come by, you pull the 10th one and you ask them about their favorite book. That's more systematic. Stratified means you're breaking it into smaller groups. So you're asking 10 people in every class, or in every class, or in every grade, 2 people in every class, or something like that, right? You're breaking the bigger group into smaller groups and then sampling those probably systematically or random. And then quota sampling is trying to represent the same proportions. So if we know, for example, that the students our student body is 60% female and 40% male, you're trying to be faithful to that breakup, your sample should include 60% female students and 40% male students, right? From however you're going to do it, either stratified or systematic or random. You want to try to have this same percentage breakup. That's quota sampling. Not a massive part of the curriculum, but just so you know. Numerical data is is our bread and butter, and we want the numbers out of this. They can be discrete or continuous. Again, like discrete means whole numbers, and so like the number of gremlins that might be in your closet is a whole number. 1, 2, 3, 4, 5. Right? It would be really weird if you had like half a gremlin in your closet. So you don't have like 4.5 gremlins. You should probably have just 5 gremlins. And so the number of them is discrete, but probably like their heights. It's okay if you have one that's like 5.2 centimeters and another one that's like 6.7 centimeters. Having a decimal height is fine, right? So that's continuous because it can continue between 2 integer values. So we're going to take this data and be able to present it in a way that's absorbable to more people. This is the data set. Maybe this is your IB exam scores, making stuff up, right? 5s, 4s, 7s, a couple of 3s. And what you could do is take raw data by tallying. This is like the score on the exam. So there's 3s and 4s and 5s and 6s and 7s. Those are all the things that we could get. And I'm just tallying them as they come through. So every time I see a 3, I make a mark. Every time I see a 5, I make a mark. And this is the tally. And afterwards, we count them up and say, oh, there's 2 of those. Hey, there's 9 of those. Da, 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 da. And so this is kind of a running total as we're counting through and doing things quickly. And this is the frequency. I have a 3 came up 2 times. A 4 came up 9 times. You can turn this into a column graph and say, I didn't have 1s or 2s, obviously, but I had 2 3s, so that's this, and I had 9 4s, so a 4 came up 9 times, right? And a 5 came up 13 times, so the 5 came up 13 times. This is a column graph. That's a nice way to show data. You can also do a dot plot, which is the same thing, but just kind of with dots, right? This is 2 sets of 3. The frequency tells you how many times it occurs. All right. We can make a frequency table, like I said before, with a tally, how many times a 1 comes up. Maybe these are AP scores or something like that. And so since there were 8 1s, you put a frequency of 8. Just kind of, this is a summary of the tallies. Often we'll use a relative frequency column to show how many of these over the total. So if you add up all the frequencies, you should get the total number of tests. This is the 30 AP tests. And so to find the relative frequency of 1s, how often does a 1 come up? Oh, 8 out of those 30 is the percentage that you get a 1. So 26% of the students got a 1, so a quarter of them, right? So this one would be 9 out of 30, a little bit higher, etc., etc., etc. You'll also notice that if you add up the percentages, they should add to 100 because you need to have 100% at some point. So you can tell if you've messed it up or not. So you can say, hey, what's the probability? You could use this with probability. What's the probability of getting a 5? Oh, 2 out of the 30 got a 5 just based on our sample. That's 6, almost 7%. So you have a 7% chance of getting a 5. All right, we also display numerical data with these column graphs or histograms. The difference between the two is that there's gaps in column graphs and histograms don't have gaps. We use column graphs for discrete data, and we use a histogram with no gap in a continuous data because this could be, maybe this is the number of gremlins or in our closets, and this is like 1, 2, 3, 4, 5, 6, 7, and we ask everybody, you count the gremlins in your closet and you report back, and this many people said 1 and this many people said 2, etc., etc. And there's nothing really in between. But if you ask about the heights of the gremlins in your closets, there would be between, like, this is 6, this is 7, this is 8, this is 9, and all of these would be gremlins with height between 6 and 7. And then immediately, this next column is between 7 and 8. And because there's no big change between those, we put them right next to each other to show that this is all the gremlins. They're like, if you counted up and this was like 6.1 and somebody had a 6.3 and a 6.7, all of those are in this bar. And then immediately in this one is 7.01 and 7.6 and 7.8 are stored in this column. And these two, the high 6s and the low 7s, are right next to each other. So we put them stuck next to each other in the histogram. I can give you some more examples in class, but continuous data, histogram, no gaps. All right. When you build those, often we'd expect this beautiful symmetrical pattern. If you were looking at the distribution, most are in the middle, and they kind of taper off. So taper off to the ends. Maybe this is like lengths of the kangaroo tails or something, and most kangaroos have an average tail length. Some have really long tails, but not very many of them. Some have little short tails, but not very many of them, and on average, symmetrically distributed. So that's symmetrical. This is skewed. This is like that. It's like somebody pulled this side over, right? So you're pulling this end, and we're skewing this to the negative. So this is negatively skewed. It's skewed in the negative direction. It's being pulled away from a symmetrical curve. Similarly, this is a positive skew because it looks like somebody pulled a symmetrical curve, pulled the tail out this way positively. So this is a positive skew. Sometimes they say right or left skew. Oh, good, I like that, thanks. But we'll use positive and negative. All right, we're going to do problems from 6A and 6B as you learn statistics. Check those out, and I'll see you later.